Hi, everyone. My name is Joleigh Honey, and I serve on the Conference Board of Mathematical Sciences, otherwise known as CBMS, and I am also an author and consultant of Mathematics Vision Project and Open Up High School resources. I'm excited today to share with you strategies for success, asset-based routines that make the difference. So today, strategies for student success, talking about asset-based routines. In our session, our learning intentions will be that we will understand how to provide all students access to the most important course level content using the major work of the grade band concepts. We'll also identify and understand how asset-based routines increase student engagement and sense making, hence the key to student success. And at the end of today, or at the end of our session, our success criteria is that hopefully you'll all leave with tools and strategies that will successfully implement asset-based instruction using course level content for all learners. So first of all, we start with reviewing concepts so many times that students have learned in the past thinking that we have to reteach prior knowledge before students access this year's contest. This is a total myth and takes up a huge amount of our precious time. Before the year begins, strategy one is to deepen our understanding of the major work of the grade band concepts. The purpose of this, and so let's look at an example. In high school or in grades 9 through 11, a major concept is for students to understand, compare, and represent functions. We want students to build a conceptual understanding of these functions using multiple representations. And then through using these representations, and they become tools for students, they then make connections, and over time, students recognize and define functions by their rates of change. With this knowledge and with relevant high-quality tasks, students become flexible in comparing and representing functions. Let's take how we use the major work of the grade band, so grades 9 through 11, and hone in on one specific grade. This particular document was created during my time as the state math specialist of Utah, so it's a secondary math 1 set of standards. Algebra 1 would be very similar, but also include quadratic functions. What you can see is using the major concept to understand, represent, and compare functions, we find many standards that align. We can also see experiences students had in prior years and recognize that we're building a strong web of mathematical ideas for work they'll do throughout high school. This leads me to share strategy 2. Start the year with the most important grade level content via the understanding of the major work of the grade. Instead of reviewing, start with grade level content and provide just-in-time supports as needed. Asset-based instruction provides access to grade level content for students, and that also with the understanding that math is a web of ideas. So this takes us to strategy 3. I'd like for you to look at the pattern that is on the right side of your screen, and why I share that strategy 3 is implement tasks that provide multiple entry points and use student thinking to capture learning goals. Please take a couple of minutes to identify how you see this pattern grow. Draw pattern 3 at 3 minutes and pay attention to the ideas you have about how this pattern is growing. In the chat box, please share how many dots are there at 3 minutes, how do you know, and share how you are seeing the pattern grow. So put all 3 of those things. How many dots are at 3 minutes? How do you know? And share how you are seeing the pattern grow. While you're typing, I just want to say in a class situation, I would now ask students to work independently for a couple of minutes, create different representations to make sense of how they're seeing this pattern grow. I would monitor the room. I would check on students, see what's happening with their work, support students who are having a struggle getting started. And then after enough independent think time has happened, I would ask students to share their work with a partner or in their small group. As I continue monitoring, asking questions, listening to students as they share their ideas, I would look for different representations and listen to student thinking so that I could select students to share their strategies. What I'm looking for is that all students are able to see the +4 growth from 1 minute to the next. So let's look at some student work. Several students saw the pattern grow similar to either student A or student B. Did you see it one of these ways? The ways of thinking about this pattern is likely different. Having students explain their thinking to the teacher and to their partner first assists them in participating and practicing and understanding their reasoning. This support is important so that they have time to share and think through their process before presenting to the whole class if they are students who are selected. Who is selected to share first in this situation does not matter, as long as the student thinking is valued and that the takeaways are noticed by the peers of these two students. It's our role as educators to make sure that we ask questions that promote discussions to see what each is highlighting in the math problem. As you're looking at these two, I want you to notice that one of the things that became part of the conversation is that student A said that they noticed one group of 4 being added each time. So you can see the box of the one group of 4 and as it goes out. While student B noticed it more as petals or flowers, and they're seeing this as 4 groups of M minutes or however much time has gone by. So what I would like for you to think about is looking at student A and also thinking about other students who have other strategies and ideas that are noted here. So at this time, there's a lot of information that's in the classroom. Student A may have really honed in on how they're seeing this pattern with the green and the purple. Whereas you have another student who had a table and a graph, and another student who wrote n is equal to x plus 4, and another student who wrote y is equal to 4x plus 1. In our class discussion, we really want to highlight and value how all of these things have genius in them, if you will, or in other words, ways that students are seeing and making sense of the problem. And not necessarily honing in on maybe perhaps what's not right or not complete in the situation. So for example, the student who wrote n is equal to x plus 4, I hope that you can see that what is right in their thinking is connected to what is also in the graphical representation and in our table of values, and that we're seeing that plus 4 happening over and over. This is an awesome thing for a student in the room to have because this kind of highlights the idea of recursive thinking. And this is exactly where you want to bring this up in algebra or math 1, is that idea of recursive. And then from here, we can use student language to be like, our next value is equal to our current value plus 4. And so using that student thinking can really support us in this work. At the same time, we can look at the petals, if you will, and similarly, we can also see the plus 4s happening over and over, and we can see that connection that we want students to make between the table, and then they can see that rate of change in the graph, and then we can also then connect how that plus 4 in a recursive idea becomes important in the explicit equation of 4x plus 1. We just went through that pretty quickly, but of course, in a class period, there's all kinds of rich discussions that can happen there. What I would like to do is share with you for the next few minutes and go through and think about how this particular task is, first of all, in the grade band of high school, focusing on functions, and then in the grade itself, which was strategy 2, focusing on important work. And then we had strategy 3, which is implement tasks that provide multiple entry points. I'm hoping that you notice that there are lots of different ways that students could have looked at and seen how those dots were growing from 1 minute to the next. So then here we are, strategy 4, equitable access to content. And this is from the True Dimensions framework, which is around equitable access to content, which is The extent to which classroom activity structures invite and support the active engagement of all of the students in the classroom, with the core disciplinary content being addressed by the class. Please note that it is not the teacher directing students to think about how to watch the pattern grow. It is not the teacher who is creating the table of values. It is not the teacher who is telling students this is the explicit or this is the recursive equation. It is the core disciplinary content that the class is paying attention to, and they're using it and they're using their own thinking and their own reasoning, and the teacher is positioning students to use their thinking and reasoning and sense making, um, so that the students are successful with what they're doing. Also note that in a whole group discussion, it would be really important for the teacher to draw upon multiple competencies of different students, and that over time and different days, that all students are ending up sharing their ideas. Because what you'll notice in the equitable access to content, the second paragraph from the True Framework mentions classrooms in which a small number of students get the most airtime are not equitable, no matter how rich the content. It's important that all students are involved. This way, it makes it so that everyone sees each other as valuable contributors. It also makes it very important that we make sure that we are creating access for all students. So to continue strategy 4, what I also would like for you to note is in that task and in enriched tasks, we are providing student choice. Students were selecting the representation that makes sense to them. They were building understanding by sharing their ideas and strategies, and also listening to the ideas of their peers. And then because they were doing those things, we also have student voice, position students to be positive contributors of their reasoning and sense making. Please notice that the student who wrote, I think it was n equals x plus 4, that the teacher was not trying to tell them that they were wrong or redirect their thinking. They were actually like, that is really powerful and important information. Let's build on that. Let's talk about that. And that's how students are coming to think about recursive thinking, which, by the way, is extremely important in mathematics, to be thinking about recursive thinking. The goal is not to get to explicit. The goal is to see and recognize the power and value of both of those things. Another thing about providing student voice is thinking about how we are going to use asset-based instructional routines that promote partner or small group discourse so that all students see themselves as capable of learning the goals of the lesson. Also, when we have student voice, how we select, sequence, and connect student voice using their work is to then share and build the understanding of the mathematics. Please note, it is really important that when we are selecting, sequencing, and connecting student work, that we are thinking about doing that in many different ways. We do not always want to start with the simple solution, building to the more complex. Students are aware of that, and that also does not honor and value what mathematics is about. Mathematics is a web of ideas. So really thinking about what are different ways that you could select different students, and the goal is to compare what's similar, what's different. And it's not about which one is more complicated or which or to compare in those other ways. All right, so here we are. Routines that promote agency and identity, or in other words, strategy 5, using asset-based instructional routines that promote learner identity and agency. So discourse, it really just comes down to discourse. When we are thinking about this, for those, many of us I know are familiar with the 5 practices for orchestrating productive discussions. For the past 10-ish minutes, I have actually shared a task and have used those 5 practices. So one of the biggest routines that I think that really the 5 practices are a culmination of a bunch of routines is that when you're using the 5 practices for orchestrating discussions, what you want to do is you want to think about how we are going to anticipate. So what are the strategies that students are going to bring to the table? And also what misconceptions are common, And then also, what are different ways that I can be thinking about as the teacher that I'm going to select students to bring out a lot of different ideas? How am I going to look for different representations so that when students go to do the next task, that they have seen other representations that their peers have done so that they also feel more confident in creating more representations. As I mentioned earlier, monitoring is walking around, listening to students, using their ideas to present the conversation and to bring the content out, if you will, not listening to them so that I can correct their ideas, but listening to them so that I can amplify their voice and share their ideas. And then we also mentioned selecting, sequencing, and connecting, really having opportunities for students to be able to connect to one another's ideas and to build that network or the web of ideas in mathematics, if you will. So let's talk about this agency, authority, and identity before we move on to the other instructional routines. In the True Dimension framework, we also have the extent to which students are provided opportunities to walk the walk and talk the talk. This is to contribute to conversations about those disciplinary ideas, to build on others' ideas and have others build on theirs in ways that contribute to their development of agency, which is the willingness to engage, their ownership over the content, and the development of positive identities as thinkers and learners. So, thinking about how we are going to promote students' positive identity, which, by the way, sometimes we can also unintentionally have, instead of it being an asset-based routine where we're creating a positive math identity, there are times where we can unintentionally redirect students and do so in such a way that makes them feel like they are less capable mathematically. So we really want to be aware of and careful with that as well and paying attention to that. So let's talk about the fact that in addition to the 5 practices where there's a lot of think, pair, share opportunities, that there are also other spaces where think, pair, share is so important. So for example, explore phase of a task. So there are different curriculums out there, including the Open Up Resources High School Mathematics, where we have launch, explore, discuss, or launch, explore, summarize. And the launch is where the teacher spends a few minutes hooking, motivating students, sharing context, making sure that they are familiar with what they are going to be doing with the expectation, but also not stealing the joy of the mathematics, like not telling students how to attack a strategy or provide the solution path as much as making sure that they know what they're going to be looking for when they're out there. The explore phase, while it starts with independent think time, it really is the wonderful space where students, after they've had time to think about the problem themselves, they share ideas with their partners. And through that sharing, they actually are building on each other's knowledge. They're also more structured turn and talk. So for example, a teacher may be like, okay, we're having a discussion in the whole group discussion. And there's a space where the class has all absorbed certain information. And the teacher now wants you to turn and talk about something that is explicit. Those turn and talk times are great if it's usually like have person A go first, spend some time, then person B. It's always important, of course, that the turn and talk is connected to the content that they're learning and can also include things like how are you self-aware or how are you doing things to build relationships? So thinking about social emotional learning of how are we learning about the mathematics and valuing the mathematics together. Another example of a think, pair, share is the 2-minute talks. I first heard of the 2-minute talks through Pam Sita and Kendall Brown's work in Choosing to See. And I really love the idea of students having a topic that they are, so for example, in this situation, it might be like, share everything you know about linear functions. And you have person A go for 1 minute, and they just openly talk about all of the characteristics and things they know about linear functions. And then person B goes for 1 minute and adds to that. That would be a 2-minute talk. Another instructional routine that is so important in our world are math language routines. And there are 8 math language routines, and I know that I only am sharing 2 of them here, but one of them is compare and connect. And I chose that one because I was thinking about the task that we looked at today. And while it was very brief, one of the things that happens during that whole group discussion, and I wanted to highlight, is there are different ways students are working on the problem of the growing dots, but different students bring different things to highlight. And so being able to compare how are those ideas similar, but also how are they different. One student was seeing a group of 4 dots increase each minute and the boxes. And then other sets of students were seeing 4 groups of those dots. And if any of you are K-12 people, I'm hoping you're loving the number of groups and the size of groups conversation that we're having here. But and then also being able to connect either of those geometric model representations to the table of values so that students get comfortable that when they see arithmetic sequences or linear functions, that what is important about those is that you have a constant first difference in your table of values when you have consecutive terms, and that you also end up with a line, or that you can see that constant rate happening in your graph. And you also see that constant rate happening in both your recursive equation as well as the explicit equation. And how are those similar? How are those different? Another math language routine is discussion supports. So one of the things that's great is when we saw student A, if that student's name was Alan, then we would talk about Alan's strategy as we move forward through the unit. And then student B, who saw the petals, if you will, or the flowers, the bike spokes. Student B, if that was Bernie, and don't ask me why I'm thinking Bernie, but if it was Bernie, we would talk about Bernie's strategy. That's a different way of having discussion supports that promote and acknowledge that students have these ideas and strategies. And another discussion support is sentence frames. Thinking about our multi-language learners but also all learners, in helping them develop that academic language, because we know in math that we kind of also have our own language. So not only are we supporting students with disabilities and multi-language learners, but all students to say, I saw the pattern grow like blank, and it made me think blank, or other ways to use sentence frames. So in conclusion, our takeaways for today happen to be our strategies, which is when we really want student success, make sure we start with and know our major work of the grade band. In K-8, you can see that through Achieve the Core. And also at the Utah State Board of Education, we have these in grade 8, but we also K-8, but we also have them in high school. The second thing is make sure at the beginning of the year, we start instruction with a focus on the most important grade level content. Provide those just-in-time supports as needed and when needed, as opposed to thinking that students need that before we even begin. Also, implement tasks that provide multiple entry points and align to that most important grade level content. And equitable access to content means that there are multiple entry points. It means that we have multiple opportunities. It means that we give students the opportunities to walk the walk and talk the talk. And that in order to walk the walk and talk the talk, that we are implementing asset-based instructional routines that promote that learner identity and agency. So thinking about the 5 practices for orchestrating discussion as a powerful, equitable tool. Thinking about how math language routines develop and support student language, and also develop them valuing each other as positive contributors to the mathematics, and then also multiple facets of think, pair, share as high value and high quality instructional routines. I would love for you to also think about a reflection. So, if we are thinking about what are some tools or strategies, whether it's for your own classroom or for teachers that you support, what will you do? What action step will you take from today to further promote high quality or asset based instructional routines that's specific to grade level content for students? My name again is Joleigh Honey, and here is my email and my Twitter handle. And we are ready for questions. I actually have two windows open right now, so it's kind of creating a little craziness. But I just want to say thank you so much for being here. And I hope that the session was meaningful to you, that when it comes to thinking about high dosage or strategies for student success, that we're thinking about those takeaways. What's most important for students to learn in a particular grade level? How do we encourage students to reason and talk about mathematics? And then how are we also using that student voice and choice to support students' identity and having them feel successful in math class? Giving them the opportunities to feel empowered, and through building their positive identity, increasing their success. Jessica, it was so great seeing you from Nashville today. Looking forward to seeing you in a little bit. Thank you for joining the session. And Lindsay, thanks for all the comments. And Rebecca Peterson, I can't wait to see your session later this afternoon. Oh my goodness. And I have Ken Kriebel, Kevin Dykema, and David Barnes all making comments in the chat box. Ah, love you guys. And thanks everyone. Michelle, thanks for the heart and the stars smiley earlier. And just everyone, thank you so much for just engaging in the chat box. This has been so much more meaningful to me because of the contributions that you've made. I've loved it. Thank you so much. In the meantime, well, I guess there are just a couple of minutes. I am going to go ahead and go into the chat box and put in some resources that I used from today. So in addition to the total robust understanding framework, so because apparently I also have time, which I think this is the first time in I don't even know how many years where I've had a session and I'm like, oh, there's actually a little bit of time at the end. I do want to share that I have a session next week that focuses on diverse learners. And so please join me for that because we'll also be talking about the major work of the grade and how to use that to support all students in being successful in mathematics, but more specifically talking about strategies that make it so that students with disabilities have choice and voice in how they show their understanding of the mathematics. So, you guys, I just want to take this moment and say thanks one more time. Thank you for coming. I hope that you get to watch the video again later and reflect again on if there is anything that you can add to your list of strategies to increase student engagement. And thank you all so much for being here.